Hello guys, how are you today? I hope everyone is doing great. So today I'll be explaining the chemistry AMS of term 3 week 8. So let's start with the first question. An aluminum alloy is used instead of pure aluminum in aircrafts. Why is aluminum alloy used instead of pure aluminum? Well, for sure, if it's more abundant in nature, it's definitely not going to be in benefit to us if it doesn't have any good properties that we need. If it's more reactive than pure aluminum, pay attention, we're using it where? In aircrafts. If it's more reactive than pure aluminum, that means if you put it in an aircraft and the aircraft flies and it reacts with the oxygen in the air, this could damage the airplane, the aircraft, and it could cause disturbances in the flight, which is not what we need. We need something that is strong, something that is resistant to these things. So definitely more reactive is not it. Aluminum alloy is stronger than pure aluminum. This is definitely a good reason on why you could use it for an aircraft. If it has a lower melting point than pure aluminum, so let's say you were to go at higher speed, maybe because of the faster speed the temperature increases rapidly, because the temperature is increasing rapidly, it could cause the aluminum alloy to melt, which is definitely not a reason why it is used, because we don't want it to melt. We need the plane to be whole. We don't want anything to melt. Okay, we move on to question number 2. A single covalent bond formed between two atoms where only one of them shares both electrons of the bond with the other is called a what? So, this is called a dative bond. What you need to know is it's a single covalent bond when between two atoms, but only one of the atoms shares both of the electrons and the other does not share any electrons. So, for example, if we did NH4 plus, actually my bad, it's like this, NH4 plus. If we were to draw its figures, or its like diagram, we first have to break it into its ions. We know that N is N3 minus, and each H is gonna have a positive charge. So if you were to draw the electrons based on the periodic table, you would have nitrogen over here. You look in the periodic table, how many valence electrons does nitrogen have? We know that nitrogen, it has an atomic number of 7. If you do its electronic configuration, it's gonna be 2 and 5. So it has 5 valence electrons. That means 1, 2, 3, 4, and 5. Hydrogen, it has an atomic number of 1, meaning it's gonna have 1 valence electron. So this is gonna be H, my bad. This is gonna be the H over here, it's gonna share one bond. We're gonna have H also over here, it's gonna share another bond. We're gonna have H over here, it's gonna share another bond, but pay attention, this is NH4 plus, we have 4 hydrogens. So now we're gonna have hydrogen over here. Already in the bond, we are given the 2 electrons from the nitrogen. This is what we call a dative bond. And we have the extra plus charge that is remaining for the NH4 plus. So this is the definition of a dative bond. This is what a dative bond looks like. Okay, we move on to question number 3. What does it say in question number 3? When petrol burns in a car engine, catalytic converter is installed in the car exhaust. Okay, they convert the pollutant gases. Okay, very important. What are the pollutant gases you need to know of? There are 2 main ones. They are what? Carbon monoxide and nitrogen monoxide. These, they come from what? From the catalytic converters. So whenever you see catalytic converters, the 2 main pollutant gases you should know of are carbon monoxide and nitrogen monoxide. Okay, they will be released by the engine into less harmful products. Okay, so that's it for question number 3. We move on to question number 4. A mixture of miscible liquids having close boiling point. So what does miscible mean? Miscible means that they mix with each other. If the liquids mix with each other and they have close boiling points, how is it possible to separate them? Very simply by a process called fractional distillation. We move on to question number 5. It says, which of the following is the electron configuration of the sodium atom Na11? Very simply, they did not say ion. Pay attention. If they said ion, then you would have to take it as an A+. But they said atom, so you will just take it as an A. It has a proton number of 11, so based on electronic configuration, it's gonna be 2, 8, and 1. So this is how you do the electronic configuration of what? Of the sodium Na. We move on to question number 6. What does it say? We need to separate organic and inorganic water pollutants. Organic water pollutants, they are what? They are pesticides. Organic, yeah, they are pesticides and sewage water. Whereas for the inorganic, they are what? They are inorganic fertilizers and heavy metals. Okay, please remember these for the AMS tomorrow. We move on to question number 7. So, question number 7, what does it say? It says a student is asked to find the pH of a solution. In an experiment, he prepares an aqueous solution of hydrochloric acid, HCl, by dissolving 0.0800 mole of the acid in 250 milliliter volumetric flask filled up to the calibration mark at 25 degrees Celsius. First part, they want us to find what? The concentration of hydronium ions, which is the H+ ions in the solution. Before we start with anything, separate the HCl. Let me do it like this. You will get H+ and Cl-. Now, how many H do you have? How many Cl do you have? You have one H, one Cl. That means they are balanced. Very simply, if they are balanced, then that means each one of them is going to take the number of mole based on the coefficient. So this has a coefficient of 1 and this has a coefficient of 1. So the number of moles of H+ and the number of mole of Cl-, it's going to be 1 times 0.0800 mole. Whereas let's say, for example, we had MgCl2. Oh no, that's not an acid. My bad. What if we had, for example, H2SO4? If we had H2SO4, then you would have to break them into their ions, H+ SO4 2 minus. You will have 2SO4 and only one H+. It's not balanced. To balance it, you will have to put a 2 over here. And the number of moles is going to be 2 times N, which is the corresponding number of moles. Okay, so now we can find the number of moles of the H+ because we need to find what? The concentration of H+. And we know that the equation of concentration, it is number of moles over the volume. So the number of moles is going to be 0.0800 mole. However, the volume we have, it is in milliliters, so we will need to change it to liters by dividing by 1,000. When you divide it by 1,000, it's going to be 0.20 or 0.250 liters. You have the number of mole, 0.0800, over the liters, 0.250. You will put it on your calculator. And you are supposed to get an answer of what? Of 0.32 molarity. M is the unit for what? For the concentration. However, they wanted the 3 significant figures, so you're going to write it as what? As 0.320. We move on to part 2. What does it say in part 2? It says give your answer to 3 decimal places the pH of the solution. How do we find the pH of a solution given its concentration? Very simply, you should know that the pH is equal to minus log what? The concentration. So this means concentration. Okay, so how do you put it on your calculator? You do minus and then you click on the log. You put the concentration. What's the value of our concentration? Is 0.320. Okay, and you're supposed to get a pH, which is what? A pH, which is equal to 0.4948. They want it to 3 decimal places, so you will round it. It will be 0.495. So the pH is 0.495. We move on to question number 8. What does it say in question number 8? The following shows the chromatogram of a dye that was separated into its 3 components, A, B, and C, using paper chromatography and a solvent X. Choose the component of the dye that is least soluble in solvent X and has the most affinity to the paper. Very simply, the closer it is to the baseline, okay, the closer the dye is to the baseline, what does this mean? This means it is less soluble, or it's the least soluble component, and it has what? It has the most affinity. So the closer it is, that means it's less soluble and it has more affinity, whereas the farther it is, if it's over here, for example, this is gonna be what? This is gonna be the most soluble and it has what? The least affinity. So in this case, which one is the least soluble and has the most affinity to the paper? It is dye C, because it's the closest to the baseline. Okay, we move on to the next part. Give the RF value for a component A. How do we find the RF value? Very simply, to find the RF value, it's gonna be the distance traveled by component A. So for example, this is the distance of component A over what? over the distance to the solvent front. So component A, we need to find its distance from what? From the baseline. Very, very important. Its distance from the baseline, which is what? Which is 10 centimeter, over its distance from what? It's the distance of the baseline. So from the baseline to the solvent front, it is what? It is 12 centimeters. So you'll put it on your calculator and you will get an answer of 0.83. I think they wanted it to significant figures, so 0.83. Again, the equation to find the RF value is what? It is the distance of the component from the baseline versus the distance of the solvent front from the baseline. And versus means over, by the way. Okay? Move on to question number 9. So this is question number 9. What does it say in question number 9? It says, a student wanted to find the maximum mass of aluminum oxide, Al2O3, produced on a sample of 0.8 moles. You have what? You have the number of moles of aluminum react with excess oxygen. That means aluminum is what? It's the limiting reagent. Okay? So, since aluminum is the limiting reagent, that means all of the equation is going to be based on it. So, if it was originally 4 moles of aluminum and then it became what? It became 0.8 moles of aluminum. That means 2 moles of Al2O3 is going to be what? It is going to be 0.4 moles of Al2O3. How did we find this? Based on cross multiplication. So, again, 4 moles of Al will give us 0.8 moles of Al. So how much or how many moles will 2 moles of Al2O3 give us? It will give us 0.4 moles of Al2O3. Now that you have the number of moles of Al2O3, you will be able to find what? So it's 0.4 moles of Al2O3. You'll be able to find its molar, not its molar mass, my bad, its mass. How do you find its mass? It's very simply the number of moles multiplied by the molar mass. So the number of moles, which is 0.4, multiplied by the molar mass of Al2O3. How do you find the molar mass of the Al2O3? It's 2Al, that means it's 27 times 2, plus 3 oxygen, that means 3 times 16. Put it on the calculator, so 0.4 times. Do not forget to put the brackets. 27 times 2 plus 3 times 16. You will get an answer of what? You will get an answer of 40.8 to 3 significant figures. So perfect, our answer is 40.8 to 3 significant figures. Move on to question number 10. What does it say in question number 10? It says, the empirical formula of a compound XCH2O. If the molar mass of the compound is 60 grams per mole, what is its molecular formula? Okay, so we're given what? Its empirical formula. So let us find the molar mass of the empirical formula. It's gonna be 12 plus 2 plus 16. By now, you guys should know how to find the molar mass, so it's gonna be 30. They told us the molar mass of the compound is what? It is 60 grams per mole. So this is what the molar mass of the compound, which is 60 grams per mole. Now, how do we find out what the compound is? Well, we have the mass of the compound itself divided by the mass of its empirical formula will give us a ratio of 2. So our answer to what will we do with it? We will multiply to the empirical formula. So CH2O, we will multiply it by 2 to get C2H4O2. So very simply, our answer here it is what? C2H4O. Oops, what happened? H4O2. Very simply, that is it for question number 10. We move on to question number 11. What does it say in question number 11? The hydrogen gas, H2, reacts with carbon monoxide gas, CO, to produce methanol, CH3OH, as shown in the following reaction. When 0.5 tons of H2 gas, so that means, hold up, how many moles of H2 gas? That means 0.5 tons. How do you change it to grams? You will multiply it by 10 to the power of 6, divided by what? Divided by the molar mass of H2, which is 2. You will get an answer of 0.25 times 10 to the power of 6 what? Moles. So, 2 moles of H2 became what? 0.25 times 10 to the power of 6 moles. Okay, so the H2 reacts completely with CO gas, meaning that CO gas is the excess and the H2, it's what? It's the limiting reagent. That means the whole reaction will change based on the H2. So if anything happens to the H2, then the whole reaction is gonna change. The amount of methanol produced was how much? 3 tons. So this is what? This is the actual yield. Over here we have our actual yield. So together, let us figure out what? Let us figure out the theoretical yield. Very simply, the first step we did was finding the number of moles of H2. So it was from 2, became 0.25 times 10 to the power of 6 moles. Now, we're dealing with what? With CH3OH. If 2 became 0.25 times 10 to the power of 6, how much will 1 become? You will do cross multiplication. It's going to be 0.25 times 10 to the power of 6 divided by 2. You will get an answer of what? Of 0.125 times 10 to the power of 6 moles. Now we have what? We have the number of moles of CH3OH. Okay? Very, very important step we have over here. It is 0.125 times 10 to the power of 6. Okay? Now we need to find the mass. How do we find the mass? It is number of moles times the molar mass. So 0.125 times 10 to the power of 6 times what? Times the molar mass of CH3OH. What's the molar mass of CH3OH? It is very simply 12 plus 3 plus 16 plus 1. So 0.125 times 10 to the power of 6, okay, times 12 plus 3 plus 16 plus 1. We put it on the calculator and we get what? We get 4 million grams. Now, pay attention. In the question, they wanted what? They wanted in tons. So how do you change 4 million grams into what? Into tons? Very simply, you will divide by what? You will divide by 10 to the power of 6 to get what? To get 4 tons. But they needed the 2 significant figures, so of course you're going to have to write it as 4.0 tons. So just like that, we found what? We found the theoretical yield. Now, how do we find the percentage yield? We know percentage yield, it's actual over theoretical times 100. The actual yield produced was 3 over the theoretical yield produced, which was 4, multiplied by 100, you're going to get the answer to be what? To be 75%. So very simply, the percentage yield, it is what? It is 75%. So now we move on to question number 12. What does it say? Write the electron configuration of an arsenic atom. Now, if you can see over here, what is the atomic number of... Okay, so what is the proton number or the atomic number of arsenic? It is what? It is 33 protons. Which, because we're dealing with an atom, by the way, which is going to be the same number as electrons. So 33 electrons. Now we'll need to do the electronic configuration. How do we do the electronic configuration? Well, for sure, you'd have to use what? You'd have to use the SPDF method. What is the SPDF method? Very simply, there is a way you guys should know, okay, on how to label the SPDF method. First, you start with what? You start with 2s. So you have s here, s here. Then you go backwards. So p, then s, then p, then s. So ss, ps, ps. Then you go backwards again. So look, it was s, then ps. Now you're gonna go dps. So it's gonna be d, p, s, d, p, s. Okay, so we're going backwards. Now finally, it's gonna be what? It's gonna be f, d, p, s. So F, D, P, S, F, D, P, S. Now, how do we number them? You start. First of all, S is always starting with 1. So 1, 2, 3, 4, 5, 6, 7, and 8. Then you have what? You have P, but P, it's in the second level, so it will start with 2. So 2, 3, 4, 5, 6, 7. Then you move on to D, but D is in which level? It's in the third level, so it's gonna start with 3. So 3, 4, 5, and 6. And then finally you have what? You have F. F is in the fourth level, so it's gonna start with 4, so it's gonna be 4 and 5. Okay, now for how many electrons it can hold? We know, first of all, that sulfur, it can hold, S. We know, first of all, that S, it can hold 2 electrons. So all of the S, it can hold how many electrons? It can hold 2 electrons. 2, 2, and 2. Whereas P, it can hold how many electrons? It can hold 6 electrons. So remember, from each one you're jumping by 4 electrons. So you start with 2, then you will move on to 6. So P can hold 6. Then we have D, we will skip by 4 again. It can hold 10 electrons. So 10, then 10, then 10, then 10. And then finally, F, we skip by 4 again. It can hold how many electrons? It can hold 14 electrons. So your structure is supposed to look something like this. Now, how does this work? Basically, what's gonna happen is that you're gonna like fill them all until you reach the number of electrons we have. So we have 33 electrons. That means we're gonna need to find 33 electrons. We need to fill 33 spaces. Okay, so we start over here. 2 electrons, that means 33 minus 4, that is what? 29. So we still have to find 29 electrons. Or you can just add them all together. 2 plus 2 is 4. We still need more, so 6, 2, 6, 2. So 4 plus 6 plus 2 plus 6 plus 2, you're gonna have 20, but we still need more. 20 is not 33, we still need more. How about we do 10? We add 10. Let's just add 10. If you add 10, it's gonna be 30. Now here's the important part. You stopped over here. It is 3d10. But you still have 3 electrons you need to put them. So you're gonna take the P, which is 4p6, but instead of the 6, you're gonna put the number of electrons you need. So how many electrons do we need? We need 3 electrons, so it's gonna be 3 over here. So very simply, the electronic configuration of arsenic atom, it is what? It is 1s2, 2s2, 2p, I'm reading from here by the way, 2p6, 3s2, 3p6, 4s2, 3d10, and then finally the last one, which is 4p3. I hope this was a good explanation. I felt it could have been better, but it's okay. If you did not understand, please do ask in the comments. I will try to reply my best. So we have 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, then 3d10, and then we have 4p3. Now one thing I would like for you guys to do is try to add all of the try to add all of the electrons together. So it's gonna be 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 3. And if you don't get 33, then there's definitely a mistake. I got 33, that means I have the correct answer. Okay, we move on to question number 13. It says pentane has the following structural formula. Select the structural isomers for pentane. When you're dealing with isomers, you need to do branching, but you cannot put the branching on the edges. So over here you cannot put a branching, and over here you cannot put a branching. You can put branching here, here, and here, or even here, here, and here. It works. But if it's at the edges, it's not gonna work. It's not gonna be counted as an isomer. So let's see the answer options. You have this one. It works as an isomer. Why? Also, another important thing I forgot to mention is for the isomers, it should have the same number of carbons. So you have 1, 2, 3, 4, and 5 carbons. That means the structural isomer should have 5 carbons. This has 5 carbons, and it's not, like, the branching is not on the end, it's not on the terminals, so definitely it's an isomer. This has 5 carbons, but the branching is on the terminals, so it's not an isomer. This has 5 carbons, but its branching is on the terminals, so it's not an isomer. This has 5 carbons, but what's even nicer is that its branching is not on the terminals, it's in the middle, so definitely this is an isomer. So this and this are isomers. We move on to question number 14. By now you guys should know the formula of alkanes. Alkanes are CnH2n plus 2. and you just substitute the N with the number of carbons you have. So 2 carbons, it's gonna be C2H2 times 2 plus 2. So very simply C2H6. Okay. Oopsies, C2H6. Move on to question number 15. Very, very important. You have to pay attention to the keywords. The metal to be protected is connected to a more reactive metal. What happens here? The more reactive metal will react instead of the less reactive metal. So that's why you will cover it with a more reactive metal. So the internal metal, which is the weaker, less reactive metal, is protected. This is known as what? As sacrificial protection. You are using the more reactive metal as what? As a sacrifice. So sacrificial protection. The metal to be protected is coated with another metal. When you see the word coated directly, you know it's electroplating. And whenever you see it's coated with zinc or it's plated with zinc or whatever, you will know that it is galvanizing. I don't know if you guys also see these weird videos of the architecture and how they fit in a tiny bedroom, 50 kids or something like this. Yeah, you notice how he always says galvanized steel? When he says galvanized, that means it's coated with what? It is coated with zinc. Move on to question number 16. Which of the following are general properties of transition metals? So what are the properties of transition metals in general? Transition metals have a couple of properties. Some of their properties that they are denser than metals. They have higher temperatures, meaning higher melting point. So I'm just going to say higher MP and BP. MP means melting point, BP means boiling point. They have catalytic properties. That means they can act as catalysts. So catalytic properties. They have multiple oxidation states. So multiple oxidation states. And now another thing, because they have multiple oxidation states, they have what? They have multicolors. They can be found in multiple colors basically, or they form colored compounds. Denser means they are heavier than other metals, higher melting point and boiling point than other metals. They have catalytic properties. They act as catalysts. For example, iron, multiple oxidation states. Again, iron, you have Fe2 plus and Fe3 plus. Multicolors, again, for iron, you have Fe2 plus and Fe3 plus. Fe2 plus is green and Fe3 plus is almost brownish red. So they are denser than other metals. They form colored compounds. They have catalytic properties. They have higher melting points and boiling points, and each may have more than one oxidation state. We move on to question number 17. So, in this question, aluminum objects are not protected from corrosion. Why does this happen? This happens because aluminum is what? More reactive than iron. Because it is more reactive than iron, it will react rapidly with oxygen gas. When it reacts with oxygen gas, it will form aluminum oxide around the aluminum that will protect it. So it prevents further corrosion. We move on to question number 18. Now, the properties of aluminum and why do we use it? Now, if aluminum is low density, that means it has a low density, means it can float, for example, on water or air or whatever. We use it to build what? To build aircrafts. Why? Because aircrafts need to fly in the air. They need to be less dense than air, of course, in order for them to fly, or they need to have a low density. Next thing, excellent thermal conductivity. This we use it in cooking utensils. For example, pots. You make pots out of aluminum in order to make them conduct the heat and cook the food. Next thing we have is excellent electrical conductivity, lightweight and malleable. This for sure, it's used in the electrical wiring systems because you need the wires to be lightweight. You need to be able to shape the wires. You need to make them long, short, whatever you want. and their wires, they need to conduct electricity. We move on to the next one, which is unbreakable and unreactive oxide. So this for sure it's in food packaging, because look, if it's unbreakable, we need to protect the food, and unreactive, meaning it will not react and corrode and cause any corrosion to enter the food and contaminate it. Now finally, strong, lightweighted and shiny. This we use it in what? We use it in the building industry to help in the structure of whatever we are building. So we move on to the next question, which is question number 19. It says aluminum is extracted by the electrolysis of molten aluminum oxide, aluminum ore, dissolved in another substance. A schematic diagram of the apparatus used is shown below. Choose the electrode at which molten aluminum. Aluminum is what? Molten aluminum, it's Al3 plus, yeah? Now, it is positive, meaning it's a cation, and the cation always goes to the cathode. So the cathode, it is what? It is the negative electrode. So it will go to the cathode, which is the negative electrode. Now we need to write the equation. Al3 plus will go to the cathode, and it will undergo what? It will undergo reduction, meaning a gain of electrons. So it will gain electrons. It will gain 3 electrons to produce what? To produce aluminum. They don't need any state symbols, so it's fine to write it like this. Al3 plus 3E minus will give us what? Will give us Al. Now, at the anode, the positive electrode, we're dealing with what? With aluminum oxide. So we got rid of the aluminum, we still have the oxygen. So O, which is usually 2 minus, will react to give us what? Oxygen gas, remember O2, plus a specific amount of electrons, because it will undergo oxidation, meaning a loss of electrons. As you can see, it's not too balanced, okay? So in order to balance it, you're going to put a 2 over here. Now, how many electrons do you have? You have 4 electrons and the 4 over here. So 2 oxygen, 2 O2 minus will give us O2 plus 4E minus. So 2 O2 minus will react with, will not react, it will give us, is 2 minus, will give us O2 plus 4 electrons, so 4E minus. They said give the overall chemical equation, okay, for the extraction of aluminum from the aluminum oxide. Basically, it's the aluminum ore, which is what? Al2O3, will give us what? Will give us O2 plus what? Plus the aluminum. As you can see, it's not balanced. To balance it, you will put A2 over here, A3 over here, and A4 over here. And we need to include the state symbols in this case. So, aluminum oxide, it is molten, meaning what? Meaning that it is liquid. Oxygen, it is a gas, so it's gonna be G. And the molten aluminum, it's gonna be what? It's gonna be a liquid. So, 2Al, 2O3, okay? It is what? It is a liquid. It will give us what? It will give us 4 aluminum, which is what? It is also a liquid because it's molten. In addition to what? In addition to 3 oxygen, so 3 O2. And remember that oxygen is a gas. Now they said the anode is made up of graphite. Graphite is what? Graphite is purely carbon. So if oxygen gas will react with graphite, it will produce carbon dioxide. So that's why it needs to be regularly changed. It reacts with the oxygen gas produced. Now choose the substance mixed with aluminum oxide to lower its melting point. It is what? It is the cryolite. Cryolite lowers the melting point of aluminum oxide. However, another name for aluminum oxide, it is what? It is bauxite. How do you spell it? It's like this. Okay, so that is it for 19. We move on to question number 20. It says, pure iron is extracted from hematite in a blast furnace. Which of the following are mixed with hematite before being introduced from the top of the furnace? First of all, what's mixed with hematite? It is what? It is the limestone. Okay, very important, the limestone and the coke. Coke is what? It is solid carbon. Okay? Choose the substance that's introduced from the bottom of the surface. It is what it is. Bottom of the furnace, it is hot air. Okay? We move on to part C. First thing, they want us to write the chemical equation of carbon dioxide from burning coke. So burning coke, we know it's carbon solid. Will react with what? With O2 gas, because remember, whenever you see burning, you will know that oxygen is involved. So O2 gas to produce what? To produce CO2 gas. Very simply. So carbon solid will react with O2 gas to produce what? To produce CO2 gas. Okay, we move on to part 2. Give the chemical equation for the reduction of carbon dioxide after reacting with excess coke. So it's CO2 will react with coke, but CO2 it's a gas, okay, and coke it is a solid, and it will form what? It will form 2CO, what? 2CO, which is a gas. So carbon dioxide, which is a gas, will react with excess coke, so carbon solid, to form what? To form 2 carbon monoxide. What is carbon monoxide? It is what? It is a gas. We move on to part 3. What does it say in part 3? It says, give the chemical equation for the reaction of hematite Fe2O3 with carbon monoxide. So, Fe2O3, it is a solid because it's an ore, so Fe2O3, solid, will react with carbon monoxide, which is a gas, to form what? This is very important for you to memorize, to form the liquid iron, Fe, liquid, in addition to what? In addition to the carbon dioxide gas. Now, I think there's a mistake because I put L and I think the answer key is 1. But in the exam, put L, do not put 1. It's wrong in the answer key. Now, as you can see, it's not balanced. So in order to balance it, you have to put a 3 over here, and a 2 over here, and a 3 over here. By now, you guys should know how to balance by yourself. So very simply, it is what? It is Fe2O3, okay? Fe2O3, which is what? A solid, will react with what? It will react with 3 carbon monoxide gas to form what? To form 2 iron liquid. Put L, do not put 1. It's a mistake from the quiz. Plus 3 carbon dioxide gas. Now, the final thing is what? It is calcium oxide, CaO, will react. Calcium oxide is produced from what? It's produced from the calcium carbonate, which is CaCO3. It will decompose to form what? To form carbon dioxide and what? And calcium oxide. So this is how we found the calcium oxide. Now what do we do with the calcium oxide? It is, by the way, what? It is a solid. It will react with sand, which is SiO2, solid, to form what? To form CaSiO3. This is known as what? As slag. Now slag, it's a sticky liquid, and it's a liquid, so you'll have to put L, not S. So CaO, solid, will react with SiO2, which is also a solid, to form what? To form the combination, which is slag. You just put them together, so it's gonna be CaSiO3, and it is what? It is a liquid. So we move on to part D. Choose the major impurity in pig iron. It is definitely for sure carbon. We move on to question number 21. Whenever you see sulfurized fuel, you will know it's directly sulfur dioxide. When you see combustion of fuel in jet engines and internal combustion, this is what? Nitrogen oxides. The complete combustion of carbon-containing fuels, it is what? It is carbon dioxide. Decomposition of vegetation and waste gases from animals, it is methane. And then when you see incomplete combustion of fuel, it is what? It is carbon monoxide. We move on to question number 22. So choose the name of the process occurring at each step of the given water treatment course. So we have step A. What is step A? Step A, it is known as screening, because you got rid of what? You got rid of the large solids. When you get rid of the large solids, this is known as screening. Step B is known as sterilization. Why? Because you got rid of the bacteria. If you got rid of the bacteria, then it's sterilization. Step C, it is what? It is the filtration. Why? Because you got rid of the fine solids. If you get rid of fine solids, then it's definitely for sure filtration. Now, when you add chlorine or UV light, this is a process known as sterilization, and sterilization occurred at step B. That means step B is the answer. We move on to question number 23. Here you have to have these memorized. Okay, you add water, the salt changes from white to blue. From white to blue, it is what? It is anhydrous copper sulfate. Whereas if it changes from blue to pink, then it is what? It is anhydrous cobalt chloride. Okay, we move on to question number 24. What does it say in question number 24? Write the chemical equation for each of the following metals with oxygen gas. Do not include state symbols in your equation. Use the smallest whole numbers to balance the equation. Okay, potassium K will react with oxygen gas to form a product, which is, we will find it out now. But it's definitely gonna be what? It's gonna be potassium oxide. So, how do we find it out? You have to take the ions. K, if you take its ion, it's K plus. O, if you take its ion, it is O2 minus. Now you have to do the crisscross method. You guys should know how to do the crisscross method. After doing the crisscross method, it's what? It is K2O. Now very simply, you have the product form. So K plus O2 will form K2O. As you can see, it's not balanced, so you'll have to put a 2 over here. And again, it's not balanced, so you'll have to put a 4 over here. So the final product is 4K, okay, plus O2 will give us what? Will give us K2O, but it's not balanced. Forget to put the 2. So 4K plus O2 will give us 2K2O. For magnesium, Mg, it is what? It is Mg2 plus O2 minus. You take their ions. You do the crisscross method. You will get MgO. So Mg plus O2 will form MgO. It's not balanced. You put 2 over here and 2 over here. Now it is balanced. So 2Mg plus O2 will give us what? Will give us 2MgO. Iron, but it forms what? It forms the Fe3 plus iron, or Fe3 plus ion. So Fe, okay, plus O2 will form what? Will form, by the crisscross method, Fe3 plus O2 minus. You do the crisscross, it is what? Fe2O3. So it will form Fe2O3. As you can see, it's not balanced. So to balance it, you will put a 2 over here, a 3 over here, and a 4 over here. So the final equation is what? It is 4Fe plus 3O2. It will form what? It will form 2Fe2O3. So very simply, this is it for question number 24. We move on to question number 25. They keep on getting longer. Okay. Choose the correct answers to complete the following. You are doing what? You're adding chlorine to methane. Methane is an alkane. Alkanes undergo what? Alkanes undergo a process known as substitution. So what is a catalyst for substitution? It is a UV light. This reaction is called substitution because what happens? The chlorine will substitute a hydrogen, or it will take the place of a hydrogen atom. Now, how do we know what are the byproducts of methane and chlorine? What's going to happen? In substitution, you're going to have carbon here. So it's, for example, CH4 like this, and ClCl. So this is what? This is the alkane, which is the methane, and this over here is the Cl2, chlorine. In substitution, what happens? Hydrogen will take place of the chlorine, and chlorine will take place of the hydrogen. Now, what does this mean? This means that the carbon stays in the middle because it does not move. So the carbon atom will always stay in the middle. It does not move. And there will always be one chlorine. So you cannot have two hydrogen. you can have one hydrogen, one chlorine, and in the center, it's always gonna be what? It's always gonna be carbon. These are two important things. And now you select the answer key based on this. This is wrong for sure. This is also wrong for sure. That makes the rest of them correct. We move on to question number 6. It says, ethene reacts with hydrogen gas at high temperature and pressure. Ethene is an alkene, and alkenes undergo a process known as addition. So choose the type of reaction. This is known as an addition reaction. What happens in an addition reaction? The double bond breaks. So now it looks like this: C single bond C, H, 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 H. And because we are dealing with hydrogen, H2, that means one H goes here and another H goes here. Now, if you want to rename this new compound, it is C2H6. It undergoes the format of CnH2n plus 2, which belongs to what? Which belongs to the alkane, right? So you will get C2H6, which belongs to the alkanes, and alkanes, they are known as saturated hydrocarbons. Now, ethanol, C2H5OH, can be produced from ethene under certain conditions. How do you produce an alcohol? So, alcohol, it's gonna come from what? It's gonna come from the alkene plus what? Plus steam. So when steam reacts with an alkene, it will produce the alcohol. So when steam reacts with ethene, it will produce ethanol. Now, ethene reacts readily with Cl2. So ethene, again, it is C double bond C and then the 4 H's. Okay? And it will react with Cl2. Now break the double bond because it will undergo addition. So it's gonna be C, single bond C, H, 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 bond here. So this is gonna be one Cl over here and this is gonna be another Cl over here. So it looks like this one over here. So this is gonna be our answer. We move on to question number 27. So give the name of the process that converts sucrose into alcohol. What converts sugar? Sucrose is a sugar into alcohol. This is known as what? This is known as fermentation. The biological catalyst that undergoes fermentation is known as yeast. What are the products of fermentation? It's definitely alcohol, which is C2H5OH and carbon dioxide. Now, how do you extract the concentrated alcohol from the reaction mixture? This is known by a process as fractional distillation. Why? Because alcohol is mixed with other things, for example, water. They have close boiling point, so you will need to use fractional distillation. Over here, they're asking for product A, so SO2 plus O2 will give us for sure SO3. This is not balanced. You will need to balance it. Maybe they will give us to balance it. But the answer is what? It is SO3. So no, when sulfur dioxide will react with oxygen, it will produce what? It will produce sulfur trioxide or SO3. Okay, now what are the conditions of pressure and temperature to produce product A? Very simply, it is what? It is a pressure of 2 atmospheres. 2 atmospheres, 200 kilopascal, and a temperature of 450 degrees. Now, the catalyst used in this process is what? It is vanadium V oxide. You guys should have it memorized by now based on how many times we did this. Now, this is the Haber process. What are the conditions needed for the Haber process? It is A, pressure of 200 atmosphere, which is 20,000 kilopascal, and a temperature of 450 degrees. Okay, now the catalyst that we use here is iron. What does the catalyst do? The catalyst will increase the rate of the reaction, so it will speed up the reaction, but the yield will stay the same, so it has no effect on the yield of ammonia. Why is that? The catalyst will not add more reactants. So, how will the concentration increase how will the concentration of products increase if the concentration of reactants is the same? It's not gonna work. So the only thing a catalyst does is it increases the speed, but it has no effect on the yield. We move on to question number 30. So we have oxidation number for N and oxidation number for O. You will assign to O an oxidation number of -2. What does this mean? NO2. N, you will assign it X plus 2. You will take this 2 over here. So this 2 comes here, multiplied by the oxidation number of O, which is minus 2, is equal to what? It's equal to the total sum, which you can find up here, which is 0. So X minus 4 is equal to 0. Move it to the other side. X is equal to 4. So oxidation number for N is 4. However, for O, it is what? It is minus 2. It's always the same, minus 2. Oxidation number for H, always the same, plus 1. So you will assign to it plus 1. Cl, we need to find it, so it's X. And O, it is always minus 2. So H, Cl, O4. H is plus 1. Cl is plus X. 4, you will put it over here. And then O, its oxidation number is minus 2. Is equal to what? Is equal to the total charge over here, which is 0. So, after solving, you will get 1 plus X minus 8 equals 0. X minus 7 equals 0. So, X is equal to 7. So, for hydrogen, it is plus 1. For Cl, it is plus 7. And for oxygen, it is what? It is minus 2. Now, finally, for the last one over here, MnO4 minus, pay attention. So, Mn is X plus 4 times oxygen minus 2 is equal to what? Is equal to the charge. The charge is minus 1. So, X minus 8 is equal to minus 1. Move this to the other side. So, X is equal to 7. Very simply, this is 7 and this is minus 2. We move on to question number 31. Very simply, choose the type of reaction described above. So, what's happening over here is the process of oxidation. How do you know? Whenever you see this over here, whenever you see the O on top, this, you will know that it is oxidation. So, very simply, this reaction is oxidation. What happens in oxidation is very simply the addition of oxygen. So, C2H5OH, okay, will give us what? Will give us product X plus H2O. What is missing from what we have? How many carbons do we have over here? We have 2 carbons. How many hydrogens do we have? We have 6 hydrogens. And how many oxygens do we have? We have only 1 oxygen. But you are adding to it O2. So keep in mind that it's also what? It's not only 1 oxygen, but it's also the 2 oxygens from the oxidation. So it's carbon 2, hydrogen 6, and oxygen 1 from C2H5OH and 2 from the O2. You move to the other side. How much do you have here? Let's start with the carbon. The carbon, here you have 0. Hydrogen, here you have 2. Oxygen, here you have 1. So what does it mean? That means for the product X that we need to find, we need to fill this, so we need 2 carbons. We need to fill this, so we need 4 hydrogens, and we need to fill this, that means we need 2 oxygens. So it needs to have 2 carbons, 4 hydrogens, and 2 oxygen. It cannot look like this, so we're going to open the answer key and we're going to see which one looks close to what we need. This has 2 carbons, it has 4 hydrogen, and it has 2 oxygen, so definitely this is our answer. Now another way you could think of it is that this is a what? This is an alcohol. When you oxidize an alcohol, it will give you what? It will give you a carboxylic acid. And what is the formula for carboxylic acid? It is CnH2n plus 1 and then COOH. Okay? So CnH2n plus 1 COOH. Okay? Now we move on to the next step. This you have to memorize it by heart. Whenever you see potassium permanganate, you should know that the color changes from purple to colorless. Whereas, whenever you see potassium dichromate, you should know that the color changes from orange to green. We move on to question number 32. What does it say? It says electrolysis of molten calcium fluoride, CaF2, is conducted using the below apparatus. Okay? Choose the identity of the element produced at the negative electrode, the cathode. Now, what happens at the cathode? Usually the cations form. What's the cation in this case? It is Ca2 plus and then 2F minus. So, the thing that will form at the cathode is the cation, which is Ca. What will form at the anode is the anion, which is what? F2. Now, to write the equations, it's going to be what? First of all, in the negative electrode, being the cathode, you will take the cation, which is Ca2 plus. It will undergo a reduction, meaning a gain of electrons, and it will form Ca. The positive electrode, meaning the anode, it's gonna be 2F minus. It will undergo reduction, meaning it will lose electrons, and it will form what? It will form F2, and it will lose 2 electrons. So very simply, Ca2 plus 2E minus will form what? Will form Ca. Oops. Whereas over here it is what? 2F. My bad. 2F minus will give us what? Will give us F2. In addition to what? To 2 electrons. We move on to question number 3. What does it say in question number 3? Okay, an aqueous solution of hydrochloric acid is an acid, pay attention, is added to calcium carbonate, CO3 minus. Important. Whenever you see carbonate reacting with an acid, first thing you know, what will form is carbon dioxide. Observation is formation of bubbles and lime water turns milky. Now, what is the net ionic equation of the reaction? You're going to take the ions, so you have H plus, Cl minus, Ca2 plus, and what was it? And CO3 minus. Okay? Now, what's going to happen is you're going to switch the ions, so it's going to be H plus will react with CO3 minus, and then Ca2 plus will react with Cl minus. Now they will form what? An aqueous solution. We do not need anything aqueous, we need the true product. So as long as it's not aqueous, then it's considered a product. So what will form? Here, when hydrogen reacts with CO3 minus, it will form what? It will form water, so H2O, plus what? Plus carbon dioxide. So carbon dioxide and H2O. Oh my goodness, we're not gonna finish. We only have 2 questions and my voice is gone. Okay. Tetrafluoroethene of the following structural formula undergoes polymerization following the polymer Teflon. As you can see, it has a double bond. That means it is what? It is an alkene. And alkenes undergo what? They undergo the addition reaction. So very simply, this reaction is known as addition. We move on to part B. Give the chemical name of polymer Teflon. How do you name polymers? Very simply, you take the monomer, which is tetrafluoroethene, and you put poly before it. So poly tetrafluoroethene. Okay, so it's gonna be poly tetrafluoroethene. Poly tetrafluoroethene. Okay, we move on to part C. If n molecules of tetrafluoroethene are polymerized, locate the correct representation of the repeat unit. So you need to now polymerize this. It looks originally like this. How do you polymerize this? You break the double bond, which is the process of addition. When you break the double bond, it's going to be C single bond C, and then you will have the F over here. And now you will have these free bonds. What will happen? You will just put the brackets around them and you will put an N over here. So this is what it looks like. Very simply, this is what the polymer looks like. So like this. Now finally, alhamdulillah, the last question. Question number 35. So, propanoic acid reacts with ethanol according to the below equation. When an acid reacts with an alcohol, more to be specific, a carboxylic acid, when it reacts with an alcohol, it will form what? It will form product A, which is known as an ester. This process, which is the forward reaction, is known as esterification. Whereas the backward process, okay, it's an ester plus the other product. I forgot to mention, in esterification, 2 products form, ester and water. The backward process, you're adding water. So when you add water, it's like you're hydrating it, so we call it hydrolysis. The name of product A. How do we name product A? How do we name esters? Very simply, you will take the number of carbons in the alcohol. How many carbons do we have? We have 2 carbons, and we'll name it. So when we have 2, it is eth. Now after the eth, you're gonna put il, so ethyl. Then after, you're gonna take the number of carbons in the carboxylic acid, so 3, that's gonna be prop. And then after prop, you're gonna put ano weight. So it's gonna be ethyl propanoate, ethyl propanoate. Now locate the structure of product A. When you're drawing the structure, it's the opposite now. Now it's the acid first, then what? Then you have the alcohol. So when you are naming it, it is what? It is alcohol, then acid. But when you're building the structure, it is acid, then alcohol. That means you're gonna first have 3 carbons, then you will have the ester bond. Remember, the ester bond looks like this. Okay, so when you find this, that means you found the ester bond. And then, so first it's gonna have 3 carbons. For sure it's gonna be like this one because it has 3 carbons. Then you have the ester bond, and then you have the 2 carbons. So the acid has 3 carbons, then ester bond, and then you have the 2 carbons from what? From the alcohol. Now finally, compound B has the same molecular formula of compound A. Choose the name of the carboxylic acid and the alcohol that react together to form compound B. I've done this many times. I'm not gonna do it like, I'm just gonna explain quickly what they want. If it has the same molecular formula, meaning it should have the same number of carbons. How many carbons does this have? It has 1, 2, 3, 4, and 5. So you have to add them. Okay, basically the answer is C. Why? Because F means 2, prop means 3, 2 plus 3 means 5 carbons, and we needed to have 5 carbons. That means very simply the answer is C. We don't even have D as an option. Very funny. Okay, so let us submit. Sorry guys, by the way, I wasn't able to do the the funny part, because I don't have time. My video is 1 hour and I don't want to waste any more time. This is not wrong. It's just because I put L instead of 1 in the answer key. It is 1. Do not put 1 in the exam. Put L. Okay, so that is it for this quiz. Thank you guys for watching. I hope you enjoyed and have a wonderful day.